Okay, so welcome back, everyone. Hope you enjoyed your quick coffee break. So our before last talk today is by Dr. Raymond Ng from Signal AI in London. So Raymond is a senior data scientist at Signal AI. His research area covers speech technology, natural language processing. And before joining Signal, Ray was a postdoc researcher at the University of Sheffield. And he actually has been a PI for several projects and co-supervised a lot of MSc, PhD students in topics related to language technology. So today, Raymond is going to talk about applying AI for decision augmentation. So Raymond, if you want to start, and then can catch up with you with more questions.
Okay, thanks for your introduction, Mo, and thanks for having me in the conference. I think very interesting talks. I enjoyed myself in the previous talks very much. So my name is Ray. I am from Signal AI. So in the next 30 minutes, I will talk about how we apply AI for decision augmentation. But before starting, so let me preempt or make a little disclaimer for what I'm going to talk about. We are a business for a B2B business. So we helped companies to discover how they are perceived in media or in the public lens. We do not particularly focus on, but for example, trading or some very professional, high-end financial narrative. But I think that some of the sharing and retrospective and experience on how we apply machine learning on that is still applicable. So this is what we're going to talk about in the coming half an hour. So to begin with, let me introduce quickly what Signal AI, our company, is. We are a company founded in 2013, 7-8 years ago in London. So we started with media monitoring business for companies. And now we have more than 180 employees and offices in London, New York, and Hong Kong. So we have achieved very fast growth in the previous years. And we are one of the fastest growing scale-ups in the comms tech business. Up to now, we have successfully fundraised a few rounds, and we raised over 50 million of fundings from top global VCs. On the business, we have more than 600 clients. So they cover different areas. There are big and small companies, private, commercial, and also government organizations, non-government organizations. You can see the list of customers, some of them here down in the slide. So we have a wide range of products. And one of our product is to give alerts to the business on reacting to what's happening in the news, and that will send out almost daily or in a more frequent than daily basis. And we have a lot of subscription and a lot of good response for many companies. For ourselves, so we have an outstanding board member. So we have Archie Norman, the chair of M&S, Simon Collins, ex-KPMG chair, and Chuka Umuna, who's previously politician, and he also has a lot of exposure on ESG. I will explain a little bit what ESG is in a moment, in case that's not clear to you. Most importantly, ourselves and our product. So we built our own proprietary AI, and you're going to hear a little bit about these in a second. And at the core of our platform, so we have commercial teams, engineering teams, and our own researchers teams together to power the engine, the Signal AI engine, which serves the business to achieve decision augmentation. So the structure of what I'm going to present in the coming half an hour, of course, I will talk about what is decision augmentation. This is the area we strive to be a leader of in the coming few years. And then I will go through some high-level challenges. What are the actual difficulties we face when we are bringing this product to our customers? And then as a data scientist, so I will go into a little bit deeper in as a text analytic system and then view that as a system point of view when we developed systems technology, what's the exact hurdle we have and some considerations or some experience sharing on how we tackle these issues. And finally, some sharing on our excellence. By the way, if there are any questions, I'm not able to see the chat window, so either leave it in the chat window or shout. Just let me know. It will be very casual. So for decision augmentation, we mostly mean some augmented system we implement in our platform to help our customers, which are mostly companies, to help to make informed decisions. So our products are developed for media monitoring, reputation management, market intelligence. Some of the examples use cases our customers have is obviously how their company is perceived in the news or in the public eyes. So helping them to monitor news and what's the reaction or what's the predicted reaction from these is one of the values we bring by using our products. And companies are also interested in their competitors. So how well their competitors doing, and because we have a platform which tries to cover as comprehensive as possible the information so that they can use that as a lens to see the industrial landscape and see how they themselves or their competitors behave and fare. We also relate companies to the bigger society. ESG is an important topic. That means environment, society, social or governance issues. This is important because when we are evaluating a company or thinking whether the company brings value, nowadays we review more importantly on sustainability, whether the company's business is creating permanent harm to the society and also to environment, and whether this means the business will be promising or not. So another area which our products can help giving information is regulatory risk or tax policy. So if there are any discussion on public policies, then the earlier we can review the trend or risk, then the companies can have ample time to make preparation and to have the right appropriate action before that actually hits them and their business. And also there are some crisis management if there will be a controversy or some rumor, because these kind of unpredicted events can just grow in a very unexpected way and affect business in really a very significant way. So the ability to capture these information as early as possible and to have the right decision to be made in the business level will be a very, very valuable asset to the company. And this is roughly summarizing what our platform and our product aims to help and solve problems for customers. So what that actually means, of course, again, as a data scientist perspective, so we talked about the technology level of how we solve the problem. We are trying to look at the data available online. So currently mostly publicly available data, but we are expanding the scope of data that we try to cover. So there are print, online, news, forum and blogs, regulatory sources, company annual reports, broadcast and radio transcripts. And then we organize these data and have AI enrichment and then run some machine learning systems like entity recognition, sentiment, saliency, topics, anomaly detection, proximity, etc. And then all these annotations will be kept in the platform. And when users subscribe to our service, they will be able to search and then retrieve these information. And then that works on top with other business intelligence tool, and then with some other agency analysis as well. And that will act as a comprehensive way to give them information to help them understand their company and also understand the market. So this is a value pyramid Signal AI likes to use to conceptually illustrate what decision augmentation is. Just another view without bombarding the listeners and audience about the details of systems and machine, but as a high level concept. So we like to emphasize, we try to get a comprehensive view of the world's data, and then we identify the areas of interest and have real-time or a very responsive and also proactive monitor on what's happening. And then on top of that, we gather insights and discover details and help to predict. So that will help business leaders and also the companies to make decisions. So that's a nutshell of what actually decision augmentation is. So up next, I'm going to talk about the challenges, particularly when in the product level, when we're trying to develop the product to solve these problems and going towards these directions. What are the particular challenges we have? First, we have to address the challenges of quality. So I remember Claire, when we were listening to the talk, I mentioned about the hurdles of interdisciplinary research, and she mentioned that the terminology is a problem. So that's exactly one example. I remember when I wrote papers, research papers, scientific paper, we say performance, and it's clear that we are talking about when we run experiment and how accurate these are. But then depends on customers, performance may mean different things. So we now use quality in a company sense or in a commercial sense to refer to the accuracy of a system. On the left, you will see an ROC curve. So that's an example metric we use to evaluate a detection system. So you have precision, recall, which judge how accurate your binary prediction is or how comprehensive your prediction covers the results. And then in case if you're not familiar with the ROC curve, then you plot different lines of the system. You have blue, orange, green lines, which represent the performance of the three systems. And you choose the line which is closest to the perfect point, which is the top left. And then you see, okay, the blue line represents the best system. And then that's our job done, because we've run our experiments, we report our results. But in the product scenario, that is completely different, because that's only part of the story. After proving what system is good, then you still have the implementation, you still have to go to market, you still have to communicate what that product is. So one important concern is the reliability. So you have to make sure that what you run in your tiny experiment space will still be the same when it is implemented in product. So what if your tiny experiments with 1,000 data points will fail when it moves to 1 million data points in an hour? That's a serious concern, and that will heavily address the perceived quality of your product. And also, how do you communicate what that product is for the customer? Because in many cases, we have seen that customers may not have understood the actual behavior of the automatic system, and then they exploit a system and then use it the wrong way, and then they report to us, hey, we got a totally wrong or failed results from the system, but it's actually not an appropriate use of the system, which caused that misalignment between the expected quality, the actual behavior. And then also, how do we have it as a service? So when it actually breaks down, do we have any fallback plan, or do we have any colleagues which can readily communicate with our customers to address these problems? So we cannot just deploy a system and then just let it sit there. Otherwise, it will not give a good outcome, or it will not help customers to solve their problems. So the second challenges I want to mention is quantity. So if I just want to recall our value pyramid, so the bottom layer is about having a complete, comprehensive view of data. For our case, we try to collect public data online data. We started with online news, printed news or online news, and then we extend to different categories of data. And now we have more than 4 million of articles ingested every day. They are coming from different geographical regions, and then they came in 24 hours a day, but sometimes during the day in busy hours, they have spike usages. So to actually implement a system which ingests this amount of data, we have to ensure that we have some effective storage of data, and then there won't be latency or queue backlog building up, because when it has some issues, then it will affect, and then it will become there will be a snowball effect, and then the products may fail altogether. So this is something we have to pay very close attention on it. And also speed. I think speed is somehow inferred from what I mentioned about quantity, but I want to especially mention the speed issue, because when we are researching or when we are trying different state-of-the-art methods, probably we always put a lot of focus on how accurate the systems are. But when we deploy it, speed becomes a very important issue. So we have to make sure that it addresses both good quality and then very fast speed when we are running the services. Customization. So we have more than 600 customers. They are coming from different backgrounds. They have different scales. They are in different business sectors. So they are looking at different subsets of our data, and they have very different requirements. So how do we address every of our 600 customers? So we tried to have bespoke solution, but at the same time, we want the solutions to be as generalized as possible. Otherwise, it will not be scalable. It's not possible that we have 1,000 different technical solutions for each of our customers. So that has been and is always a very tricky problem that we have to deal with. Finally, user interaction. I think I mentioned that a little bit in an earlier slide. So it is about how we expose our technology. So when we have a classifier system, then that has to be wrapped by some front end where users gives us data, and then we shows the results from the graphic interface, for example. So how to have an intuitive design of these interfaces so that customers can give us the data that we needed, and then we can feed them the necessary information, not to overload and overwhelm them with unnecessary details. There are a lot of tiny but very important questions to address in order to make these customers' experience satisfactory. So in the next 5 or 10 minutes, I'm going a little bit deeper to repeating this problem, but then in a system point of view, to cite some of the examples of what is the actual system challenges we have when we are building some AI solutions there. So I'd always like to use that text analytic module as a generalization, because in a while you're going to see a platform with a lot of different microservices. So a single or universal view will help us to understand the problem better, and then we can think of a solution which has a better capability, and it can be applied to different areas in our platform. So we will have some services which involve some AI, or sometimes it can be a service which use heuristics. Sometimes these services use probabilistic models or knowledge bases, and then it performs different actions. Usually they're inference action. So you load a model into the service, and then you test it by giving some data to it. In our case, the inputs to these services will be documents or document collections. So these will be some sequence data. And then we run this data through our inference module or transform or filtering module. And then this will give us outputs, mostly probabilistic, but sometimes they can be deterministic as well. So with that view in mind, then we can start building up a natural language processing pipeline. It is just by concatenating these different modules together. So these modules can be text or data cleansing. It can be a summarization module, duplicate detection, entity linking, topic classification, sentiment, or quote. So this is the illustrative diagram of our first generation of our NLP pipeline. So we ingested some print online broadcast material, and then we sequentially connect these modules one by one. So summarization will take the outputs from data cleansing, and then entity will take the outputs from duplicate detection. In the end, we have all the machine learning process finished, and then we add these into the metadata in the document, and then we dump them into Elasticsearch, and this will be the single place where user can just search and retrieve the desirable information very effectively. But when our business evolves and we have more different customers and there are different use cases, then the pipeline gradually evolves into an NLP platform. So literally, this is a cloud platform with a lot of services. So in terms of these services, they may be functionally very similar or actually identical for with what you've seen just in the last slide. But it is the way that we allow different services to connect and linked together in a very dynamic way, which creates a lot of potential and a lot of values. So of course, data preparation or some data engineering, it is very important, and then we do this upfront, and then we have the kind of the platform which allows different configurations of these services. And in the output side, apart from Elasticsearch, then we also incorporate different relational database and some of the data storage like S3 or some AWS infrastructure, so that the user can have different ways to pipe into the to the data, to the statistics, and also to the trend. And thanks to these versatile platform, so we are now also able to ingest different varieties of data. So we start to look into podcasts and also reports, and some of them are financial reports. And then we're also looking into expanding that into other formats. So I want to talk a little bit about this cloud, and I'm going to abstract the functions of the modules that I just mentioned. So you can see there are some inference services, some entity prediction or topic classification will be some of these inference service. Then we have transform feature extraction services or modules, and then we have some aggregation and update modules. The filter modules are very important because that's like the safety gateway or safeguard towards the whole cloud. So we have some filter functions which will pick up some of the naughty data or malicious data, not actually malicious, but naughty. Sometimes because when we ingest data from different ingestors and different areas, some of the data are proved to be useless, or they will prove to be creating a lot of computation load. So these filters can be useful. And also we have some very sophisticated duplication detection algorithms, which allows us to merge and combine these 4 million articles into fewer than 2 million. That means we can save a lot of computation power, and also we can send to customers what is effectively a combined story instead of poking them every time when repeated contents arise into our platform. So feature extraction and transformation is also an important module we have, because this is, as a front-end module, we extract some of the features which will be repeatedly used in the downstream process. So this is like a feature warehouse concept. Then you have generate these data, and then you put that into a data match so that they can be merged with other parts of the data and can be reused again and again. And that proves to help system efficiency and cost to a very significant degree. So we have sequential inference. You can run inference module one after the other. So an example can be you run entity recognition with very coarse criteria or with some rule-based or some heuristic criteria, so that you narrow down your scope and then you feed your first pass results to your next, for example, disambiguation module or some system with more sophisticated techniques. So that helps, again, improve the efficiency and also saving costs. And also, of course, then it's about running the appropriate technology on the appropriate place, so that you don't exploit very large model to run very simple tasks, which you can achieve by using a simple string matching, for example. And then there are some parallel inference, and that part is proved to be quite tricky in the ML platform or data platform point of view, because as developers, if you focus on only one single inference module, that will be quite simple because you only care about your own world, and then you just tune and create some machine learning service inside. But then you have to be synchronized with other parts so that it won't run too slow and it will combine nicely with the other inference output. For example, we have different, again, entity technologies. So we use different technologies to recognize entity. And in the end, we are having reconciliation modules to try to pick which of the inference systems are going to give us the most reliable prediction results. And then this is how we can achieve better quality. So we spent quite some time because it is the merging part which proved to be actually a huge engineering challenge. So this is something we're really proud of. And then we have the updates module. So that has been one-way pipeline that we have been operating. But then when our business requirements evolve, so we see that our data is changing over the time, and then we also have different target entities, and these has been constantly changing. So the idea of actually running a machine learning pipeline today, but then you have the chance to revisit that, and then you update your results with your new system configuration of your new model, and also you can overwrite what has been incorrect, is proved to be something quite valuable. So we have also put a lot of effort into doing the updates and making the whole pipeline and system repeatable and consistent in the whole process. So another point I want to mention is on the online learning. So we rely on human feedback, customer feedback, because we build our systems from most of them are supervised model, but we also think that customers' feedback when we deployed the model and the model is giving some of the results, it is important to get feedback as quickly as possible. And then we are striving to have a loop which incorporate these feedback in a timely fashion and then roll out continuously, iteratively the machine learning model so that it will have ever improving performance. So after describing all these challenges in a high level and also in the technical level, here I'm going to share with you some of the considerations we have. So I'm going to move a little bit quicker here, being aware of time. So first, it is about data. So we realized that we are actually, when we developed our proof of concept system, we always worked with a benchmark data set because we want the experiments to be repeatable, and then we want different conditions to be comparable. But that's not actually the case when we put it into before the customers, because each customers are looking into different subsets of data. There may be different distributions. So it is important to assume that there will be different distribution in different scenarios, and then make sure that we have a reasonable understanding of what the system behavior will be like under different data distributions. Second, efficiency. I think I have mentioned about the efficiency problem a lot in the previous slides. So this is an example when we use some shared upfront modules so that the results can be reusable, and it proves to be very important in terms of saving costs and also making the system more scalable and more sustainable in terms of development. Third one, dimension reduction, model compression. So it's been a very interesting field of study. There are some very conventional tricks of like feature selection, which helps to prune down or reducing the size of the problem. We can encode or encrypt the model or prune the parameters of the model, or we can run some more sophisticated or advanced technology in model distillation if we're running a large network. So we know that we can run an extra round of model distillation to learn a much smaller network. In most of the cases, it won't harm the generalizing power, but then it will help increasing the efficiency. Customization. So different customers, I have been repeating that again and again, they have different requirements, and then they looked at different areas in our data. So when we build our model, most of our models have a regularization part to make sure that it is generalizable and it doesn't overfit to particular conditions. Calibrations is a very useful trick. So once you build a model, mostly they will give you probabilistic outputs. And then the calibration is something you can really play with, and then you can have very quick turnaround, because it's amazing that you can tune your threshold, and then you will have slightly different behavior. And in most of the case, that's surprisingly that actually addressed to a lot of different customers' concerns and requests. Hierarchical ensemble model, again, that allows you to build a generalized layer in the fundamental block of your model, and then you can stick your generalized layer with some of your customized modules on top, so that you can handle the different use cases when you need it to. Fine-tuning, so we heard about the use of these OpenGPT transformer-based models. So fine-tuning definitely is a very important trick to help you achieve customization. Appellation study is something I also want to talk about, but this is not the appellation study we run in our when we are writing paper, because when we run appellation study, we usually prove that, oh, we are proposing some extra stuff in our network architecture, which is going to help, and then we write it in a paper. But in the industrial setting, we do that mostly in an opposite purpose. So we want to prove that the actual addition to our infrastructure is absolutely necessary. And surprisingly, in many cases, we can find that these additions will be good to have, but they're not necessarily the most important part that we need. So in some examples, we run appellation study, and then in the end, we decided to take away the extra components in the network. Proper evaluation is something I also wanted to talk about, but I think you will have the slides shared by organizers. The question I wanted to ask is, given your knowledge and your understanding on the ROC curve, which system you think is better, particularly in the second example? So I will leave that as an open question. User interaction communications, we talked about having built a sophisticated system with machine learning, AI technology. It is very important that we expose or we surface the strength of these systems to the customers. So we worked with a product manager and also UX designer to think really hard on how we expose each of the feature? Do we combine different features, or do we break down features into their subcomponents so that user will have a higher chance to understand the feature and enjoy the feature as we planned to? So cross-functional collaboration is also another observation that we think is important. We heard about interdisciplinary collaboration. I think that's having the same line of thoughts there, because to have a successful product, so we need, of course, data scientists, researchers to go into the very low level of developing the systems. And then we need engineering expertise to give us advice on how effective the systems is going to be run in the actual real life environment. And we also try to incorporate the ideas of product managers and also customers, beta customers, as early as possible, because they will give us the most important guidelines on where we want to put more focus on the development. Finally, I want to spend 2 minutes maybe on the excellence of what we've done. So this is the platform I've introduced. We are quite proud of the achievement. It can process more than 4 million documents daily. It has very robust real-time processing. And I also talked about the ability for it to rerun or to support repeatable process. And we also allow the process to be extendable. So nowadays, engineers can add new service into the platform within days or if not hours. So that helps us a lot in quickly iterate our products and roll out new features to support our customers. We obviously want to have very high accuracy of our product. So in the entity recognizer, which is our first class product, so we generally achieve more than 96% of F1. And we built our own sentiment analysis. We compared with some open tools and some of the cloud AI tools. Obviously, there is a training effect. So we train our own data and with our own system, but we make sure that the system is not overfitting. And we also tried a lot of efficiency optimization. So our sentiment is running on heavily optimized attention-based neural network, which is proved to be very efficient and also give accurate results. You may be a little bit surprised by the number, and this is also one point I want to highlight. So when we move to the relatively clean academic data sets to the real-time data sets, that is the discrepancy. We used to see over 80% running the same system on the same eval data. With different metadata and all the documents we have, so we started to look into the affinity, the relationships between different entities, and also we looked at the anomaly events throughout the historical events when we looked at it daily. Finally, I want to highlight 2 more use cases. So actually 3 use cases. The first one is we helped tech startups before their IPO to steer their communication strategy. So we use that tool to help them to understand the correlation between positive media coverage and IPO valuation so that they can formulate a better communication strategy before their IPO. We also power EY to their trust space score. So this is a score which is used by a lot of their customers, and it's based on 50 pillars of trust and including ethics, financial scandal, brand, so that companies can understand the trust level of the business. And we also worked with Deloitte to have a quantitative metric on supply chain resilience. So that's a combination of company, different events in different geographical areas and different topics. So that helps company to understand whether there are some supply chain risks so that they can make preparation as early as possible. If you're more interested, then this is the website, signalai.com customer stories. You can see more stories online there. So finally, summarization. We also collaborate with University, Sheffield, City University, Essex, Duisburg in Essex, and also Lancaster now. we have visiting researchers program. We have normally 1 or 2 MSc or PhD projects each year, and we tried to contribute to academic and also commercial conference, publication, and data sets. So this presentation is not possible without the help of our researchers and also engineers, marketing, and also the wire team in Signal. So that's a special thanks to them. Thank you very much for listening.
Thanks very much, Raymond. That's really interesting, and I see many familiar faces in that team. Great effort. We've got a few questions, so I'll go directly to the questions to give you a chance to answer them. So there's a couple from Jochen, but I like the second one. So he says, when you calculate sentiment analysis, if let's say Apple was mentioned with a negative polarity for the first time, so that would be like something really valuable. But if it happens again, or if it becomes redundant, how do you then reward them for like that, what he called long tail?
So I guess this is about mentioned second time in different news, right? So we didn't do anything specific to that, but if it is happening within a document, so we have the salience score, so there will be some kind of weighting within the document. If it is outside between different documents, that's obviously we didn't do anything specific, and then that will be compared to other stories because other entities will have the same effect. So in the gross, high level, macro level viewing, so they will suffer the same effect, and then they will canceling out each other.
So if I may add, the question had a bit of a business angle because a lot of data vendors, they want to be paid when you do something with their data, right? And obviously all the ones that come after the first, they're just not so valuable.
I can share a little bit of insights from what we see in the data actually. So many of these events or like attention triggering events, they really come as a spike. And then if you looked at a window of a day or two, then these spikes will quickly die out. And then it will soon canceling out each other. And then this spike then that will catch our attention. We don't go into very micro level in distinguishing whether there are 100 or 1,000. But obviously, yeah, this is an interesting angle, and I think very, very good question.
And
thanks.
Thanks, Raymond. There's another question by George. So I'm trying to just go directly to the point. So he's asking whether heuristics or human rules play a significant role for quality assurance in the final output.
For quality assurance, yes. I think we used to rely on almost a lot of human input in quality assurance, but now we are starting to trust more and more on automatic methods. So we refer to other works in quality predictions. So we recently rolled out a new modules to have our own quality predictions so that we can heavily leverage on predicted quality to judge how reliable the system is. And that proves to be, surprisingly, we are surprised by the reliability of that and also the saving of cost of that as well.
Thanks, Raymond. And we'll finish by one of Paul's questions. So Paul is asking if your language model and pipelines are changing over time, do you have to go back and rerun all the 4 million documents from yesterday, for example?
Yes, good questions. I think this was, we tried to support that from the beginning, but then as we ingest more and more documents, that proves to become a big problem from last year. So the platform we had was capable of tagging or reprocessing 15 million documents a day. And then the engineering team has done really, really serious work on that. And now it supports over 70, 80 million documents per day.
It's brilliant. Right, we're running out of time, and the last speaker is also waiting. But really, thank you very much for your time, Raymond, and really appreciate giving us an insight.
Thank you very much.
All right, so Raymond will also be available in the panel later today, so please be there if you want to ask him any more questions.